Recently, Namibia has become a hot topic in the entire global oil and gas industry following a third oil discovery announcement by Namibian state-owned oil company Namco with its partners Shell and Qatar Energy. This is attributed to the success of the Graph 1 and Venus 1 discoveries by Shell and Total Energies. Over the last year or so, Total Energies and Shell have been seriously exploring the potential for oil and gas in Namibia. These latest discoveries have gathered a lot of public interest in oil, gas, and even green energy. In this video, we're going to look at the basics and answer one of the first questions that often come to mind. How exactly are oil and gas formed? Well, when a living organism dies, it is generally recycled in one of two ways. It is either eaten by predators or scavengers, or it oxidizes through exposure to ambient air or oxygen-rich water. However, a tiny proportion of this organic matter escapes this fate, as it sometimes sinks to the bottom of the sea or large continental lakes. It is partly preserved in these poorly oxygenated environments well away from tidal currents. Here it mixes with inorganic matter such as clay particles or very fine sand and dead marine plankton. This mixture is then transformed into a dark, foul-smelling mud. Over time, this mud accumulates and hardens. Mud containing at least 1 to 2% organic matter may be transformed into source rock, eventually producing oil and gas deposits. Now, this percentage may seem low, but this is because one or more specific requirements are necessary to enable the process to take place. For instance, a hot climate is conducive to the growth of large quantities of plankton. Also, it has to be near the mouth of a major river carrying a lot of plant debris. Furthermore, there shouldn't be any nearby mountain that could limit the volume of inorganic sediment within the rock. The weight of the accumulating sediment very slowly pushes the source rock further under the Earth's crust by a few meters to a few hundred meters every million years or so. As it sinks below the ground, the source rock is subjected to increasingly high temperatures. The weight of the accumulating sediment crushes the organic matter that makes up the rock, and the pressure increases by 25 bar every 100 meters on average. At 1000 meters underground, the temperature is 50 degrees Celsius and the pressure is 250 bar. At a depth of 2000 meters, when the temperature reaches 100 degrees Celsius, kerogen starts to release hydrocarbons. Between 2000 and 3800 meters, it turns into oil. This depth interval is known as the oil window. When the source rock sinks further to between 3,800 and 5,000 meters, the production of liquid hydrocarbons peak. The liquid produced becomes increasingly lighter and gradually turns into methane gas, the lightest hydrocarbon. This depth interval is known as the gas window. There are no hydrocarbons below a depth of 8 to 10 kilometers because they are destroyed by high temperatures. Presumably, these figures may vary if it's onshore or offshore. It takes an average of 60 million years for oil and gas to form. In Namibia, both Shell and Total Energies have found light oil and some gas at a deep depth of 3 kilometers from the sea surface to the seabed and another 3 kilometers below the ground, a total of 6 kilometers from the sea level. This has been part 1 of a 3-part series on the topic of oil, gas, and green energy in Namibia. Next week we'll be focusing on part 2, so follow us and subscribe to our various social media platforms to stay in the loop as we will be diving deeper into the discovery of oil and gas in Namibia and the possible outcomes of this discovery.